Now that we're in module 3, 4, 5, we're probably going to notice that a lot of these questions seem a lot more familiar in comparison because it was pretty recent. So this first one, we're going to sketch in that graph. So the first thing that we have to identify are the roots and then how they behave. So I have two roots in this polynomial. They come from that set and that set of parentheses. So when I go to fill stuff in, note that this -2 in front is not a root. My two roots are 2 and -1. I then look for their multiplicity. Multiplicity means, do they have an even or an odd exponent? The 2 came from x minus 2 to the first power. That is odd. Odds will cross. The next one came from x plus 1 squared. That squared is even. That will be a bounce. The next thing I'm going to look at is my degree, which means I'm going to add up the exponents if we're in factored form. So 1 plus 2 gives me 3. More importantly, 3 is odd, so I know that my endpoints are going to be going in opposite directions. The next part I look for is leading coefficient. For the graphs that we do, we look to the number in front. It is negative, so I know that my right side will be going down, left side going up because odd means opposite. Next, for my y-intercept, I plug in 0 for every x that we have. So -2 times 0 minus 2 times 0 plus 1 squared. As I simplify, that gives me +4. So now I can go ahead and graph my points. So I have a point at 2, a point at -1, and my y-intercept up at 4. I'm also going to sketch in where my endpoint should be going, so I know where to start and where to finish. If it's helpful to you to label each one as a bounce or a cross, so you know how to graph it once you get there, wouldn't be a bad idea. So down at -1, we're going to bounce, go up and touch the y-intercept, and then we're going to cross through to get to the bottom part of the graph. For questions 13a and b, we are now going to work backwards and create an equation from the graph of the polynomials that we're given. So if I think back to this graph, when we took the roots from the parentheses, we flipped it. So now that we're putting it back into factored form, we're going to flip it again. So we have 3 roots at -3, 2, and 5. So I'm going to start it out. I'm going to call this one f of x, and then I'm going to flip everything back. So x plus 3 from this one, x minus 2, and x minus 5. Then I'm going to go through. I can label them bounce and cross. The ones that are crosses get an odd exponent. The good news for us is that the way it's written, they all already have odd exponents because they have that invisible 1. 2 is a bounce. Bounces get even exponents. So I can pick any even number. 2, 4, 6, 8, doesn't matter. We're going to keep it simple though, just pick a 2. The only other thing that I would need to check for is if my right side is going down, I would tack a negative sign out in front. But our right side is going up, so we are good to go here. For b, we're going to do the same thing. I'll call this one g of x. These are all crosses. So all crosses means that we're going to have all odd exponents. So all I need to do is flip them back. So x plus 3, x plus 2, and x minus 1. I can add different odd exponents if I wanted. I could add a 3, 5, 7, doesn't matter. They have those invisible ones, so we might as well keep it simple. Again, I would want to check if my right side's going down, add that negative sign in front. Otherwise, we are good to go. For question 14, we are factoring using various methods. For A and B, those are factoring sum and difference of cubes. So I know that for sum and difference of cubes, I need to have a small set and a big set of parentheses. I then take the cube root of each term. The cube root of x cubed is just x. The cube root of 343 is 7. So now I do circle soap. So 3 x's, 3 7. 3 sevens, I circle them in groups of 2 and fill them in here. So x squared, 7x, and 49. My signs, I use soap, same, opposite, always positive. Letter B is the same thing. Sometimes we forget that 1 is also a perfect cube, but it is. So again, I need small set and big set of parentheses, and then I take the cube root. With the x cubed, there is also a number. So 27x cubed, I take the cube root of the 27 and the x, so 3x. Not 3 plus x or x plus 3, 3x, they go together. Cube root of 1 is just 1. So then I do circle SOAP, write each one out 3 times, circle them in groups of 2 to get 9x squared, 3x, and 1. Signs are SOAP, again, same, opposite, always positive. Question C and D are both 4 terms. 4 terms indicates that we're probably doing grouping here. So on problem C, I'm going to split it down the middle. On the left side, they have an x squared in common. Left over is x plus 3. If I do my job correctly, x plus 3 will be left over on the other side as well. To make that happen, I'm going to take out a negative 9. So left over as our answer will be x squared minus 9 and x plus 3. So now that we're into this module, we have to check if we can factor these things further. X squared minus 9 is it's difference of 2 squares. That factors into x plus 3, x minus 3, and then I'm going to bring down that other x plus 3. So this is where we factor using one method, but then we have to check and see if we can factor it using another one. D is going to be the same, so I split it down the middle. They have an x cubed in common, x minus 2 on the inside. I'm going to take out a positive 8 with an x minus 2 left over. So now when I go to factor it, I have x cubed plus 8 and x minus 2. This one is a cube, just like we did for these problems. So I know I'm going to have to do circle SOAP. So small set, big set of parentheses. If I want to bring that extra x minus 2 down now so I don't forget it, that might not be a bad idea. The cube root of x cubed is x. Cube root of 8 is 2. I'm going to list those out 3 times each to do circle SOAP. X squared, 2x, 4. Signs are same, opposite, always positive. It asks us to solve the following cubic functions. So if I were to take away this equals 0, it would be a factoring problem just like we did above. So we're going to go ahead and factor it, and then we can solve it. So this is going to be x and 5. So the cube root of x cubed is x, cube root of 125 is 5, and then I do circle SOAP. So x, 5, 5, 5. Circle my groups. I know it's equal to 0. I add my signs in, and then we can solve. So this one is always going to be the easier of the two. This one just gives me x equals 5. For the other one, I'm not going to be able to factor. I have to do quadratic formula. So we practice that a lot in Module 2A. So I'm not going to go through what the formula is. I'm just going to go ahead and plug it in. So if you don't remember it, you need to reference back to that section. So negative 5 plus or minus square root of b squared minus 4ac all over 2a. So when we do quadratic formula, we're going to simplify underneath the radical first. We're going to find the discriminant. That gives us negative 75. So we're going to start to simplify here. Negative 5 plus or minus root negative 75 over 2. 75 breaks down into 25 and 2, 25 into 5 and 5. So the 5s match. 2 stays behind. It's a negative number, so I know I need to take out an I as well. So negative 5 plus or minus 5i root 2 over 2. I would want to check if there's any simplifying that we can do. For this one, there is not. Finally, question B for the next section for solving. I can't solve this one until it's equal to 0, so I'm going to move that 8 over. X cubed plus 8 equals 0. We solved this one just above, so I'm not going to, or we factored it rather just above, so I'm just going to kind of jump right into that. So when you factor, you should get x plus 2, x squared minus 2x plus 4. If you're not sure how I got that, I would Scroll back in the video until the part where we were talking about factoring cubes to get a little bit of help on that. Again, this one is the easy one, x equals -2. This one, again, I have to do quadratic formula on. So x equals opposite b plus or minus square root of b squared, making sure to put that in parentheses, minus 4ac all over 2a. So now as we simplify underneath the radical, -2 squared minus 4 times 1 times 4, we get -12 over 2. 12 can be 4 and 3, 4 can be 2 and 2, where the 2 will come out, 3 stays behind. So 2 plus or minus 2i root 3, because it was a negative number, all over 2. And then we're going to do a check. What can we reduce these three values by? They all have a 2 in common. So when I take out that 2, I have 1 plus or minus I root 3. I don't need the ones as placeholders here with the I or in the denominator, but I definitely need this one at the beginning. Question 16 is all about synthetic division. So they give us different directions on each problem to find what we're looking for. Letter A, we're finding the remainder. So remainder is that number in the bottom right corner. So I'm going to set up my long L with my coefficients across the top. Notice on this one how we're missing the x squared. So my number should go 1, 0, because we're missing that x squared, -5, and 80. Factors flip, so -5 goes on the outside, and then I can divide. I bring down that first number, and then I switch back and forth between multiplication and addition until I get to the very end. So this one, my remainder is -20. Question B says to write the resulting polynomial. So I'm still doing synthetic division. So I put my long L in. This one has no missing pieces, so I'm going to write it across the top. 3, -12, 13, and -12 with a positive 3 on the outside because, again, factors flip. So I bring down the 3, and then I switch back and forth. 0 with my remainder. If my problem starts with an x to the third, my resulting polynomial will start with an x squared, then an x, and then the constant. So my answer would be 3x squared minus 3x plus 4. Problem C says to find the remaining factors of the following polynomial if x equals 1 is a root. So we're going to jump right into our division. Across the top, I'm going to have a 1, a -5, a -22, and a -16. Again, no missing pieces there. This time, they give me x equals -1. They give me a root, which I don't flip. Roots stay the same. So I bring down the 1, switch back and forth. They're telling me that this is a root, so I should be getting 0 as the remainder. So my resulting polynomial starts with an x squared, then an x. So x squared minus 6x minus 16. That is 3 terms. So I'm going to do x method on it. It wants me to find the remaining factors. So -16 would be on top, -6 on the bottom. Should be 2 and -8. So my answer, x plus 2, x minus 8. Question D asks us to, again, find the remaining factors of that polynomial if x minus 3 is a factor. So same process that we're going to do on this one. 3 goes on the outside. Factors flip. This one has nothing missing, so I'm good to go 1, -3, -4, and 12. I bring down that first one, and then I switch back and forth between multiplication and addition until I get to the end. Again, they tell me this is a factor. If I get anything else other than 0, I should recheck my work. I'm going to add variables back on. This gets an x, although I don't have to include it, and we're finding the remaining factors. That is difference of 2 squares. That factors into x plus 2, x minus 2. Question E says to find all roots of that polynomial if x plus 7 is a factor. So unlike C and D, where we were just putting our parentheses, find all roots means solve completely. okay? But they give me this factor so I can use synthetic division to help me. So I'm going to put 1, 6, negative 13, and negative 42 across the top, negative 7 on the outside. So I'm going to bring down the 1, switch back and forth until I get to the very end. And I do get 0 as the remainder, which I should expect because they tell me x plus 7 is a factor. So I'm going to put my variables back on here. So what I'm going to end up solving is x squared minus x minus 6 now equals 0. So that is x method with negative 6 on top, negative 1 on the bottom. Those factors should be 2 and negative 3. So x plus 2, x minus 3 equals 0. Now that I'm solving these, I pretty much just flip. I can set them equal to 0. So x equals negative 2 and 3. Thinking about the problem, this was a cubic. Cubics can have up to 3 roots. So if we ask ourselves, where is that third root? This number out front gives you the third one.